Thereby.
Cross sections.
What did he say? I think he said cross sections. All right, we got a bunch of vertices over here. No function. What the heck? What the function? We got to find a volume for the solid that has cross sections that are perpendicular to the y-axis. What? And it's an isosceles right triangle. What? And the right angle is on the y-axis. What? Okay, let's draw a picture. So when I draw my picture, I got my vertices. There's the area of the region that we're talking about that is in question. Then we have to consider the fact that our cross sections, they're perpendicular to the y-axis. Now that, guys, you got to pay attention to that. If it says that, then you need to have functions written in terms of y, because we're choosing y values in order to find the length of this line right here. Why do we care about the length of that line? I'll tell you why we care about the length of the line. Because we need to know how long this line is of our isosceles right triangle. Now, this is how the triangle is sitting in this region. This red line is supposed to be like that red line. That's why I get all fancy with the colors and stuff. You know what I'm saying? All right, now you know that the area of a triangle is simply 1/2 base times height. Well, this base is the same as the height. Why? Because it's an isosceles right triangle, which means we don't need that h. We don't need you, h. Everybody's like, oh. All right, so now we have 1/2 b squared as our formula, but that is written in terms of b, and we don't want that. We want an area function written in terms of y. But K, because we have cross sections that are perpendicular to the y-axis, which means we need an area function written in terms of y. Oh, okay. So what are we going to put in there instead of the b? Well, we need an equation of this line right here if we want to figure that out. So I'm going to go ahead and use those 2 points, 0, 0, and 1, 2, to make my equation. Now, all you guys to do for our linear function is find the slope. In this case, it's up to right 1, so it's 2 over 1. Then you have x plus 0, 0 because the y-intercept is at 0. But we don't want a function written in terms of x. We need a function written in terms of y, so we must get the x alone. So we get y 1/2 times y. And that, my stews, is going to be your new b. That's right. If you choose this y value and you plug it into this, it'll tell you the length of this line because it'll give you what? The x. Oh. So back to our volume. We must integrate an area function written in terms of y. And so we put our lower and upper boundaries right there. Our lower boundary is 0. My upper boundary is 2. And yes, we're on the y-axis, not the x-axis, you silly ghost. All right, now I'm going to plug in what my formula is. Looks like that integrand can use some simplification. So I'm going to go 1/2 times 1/2 and y times y. That's going to give me 1/4 y squared. And 1/4 times 1/2 will be 1/8. So I put that scalar on the outside. Then you have your y squared on the inside. And now it's time to integrate. So I add 1 to the 2 to get a 3. And then I divide by 3 to get a 1/3. And then I have to plug in the 2 and the 0. I plug in the 2 first. Then you plug in the 0 and you go top minus bottom. So this is what you get. This is what you get. You plug in the numbers now. Nobody cares about that minus 0. And then when I multiply the 1 over 8 times 8 over 3, those 8s cancel out. Oh my goodness, could it be any prettier? No, I attest it cannot.